Okay, today in my honors pre-calc classes, we had, again, being the day right before our holiday break, it was a little bit crazy, but the goal for today, I'm just going to talk through generally what we did, was to take a ruler, and this is a meter stick, as I'm sure you can tell, and we bounced a ball. The kids recorded the ball with the iPad and then used that video to determine how high the ball bounced with a drop height of 100 centimeters. Okay, so then the ball dropped, and let's see if I can do that, boing, and bounced back up again. And we measured, again, if you start like this, you'd look for the bottom of the ball. We caught it on the video from the iPads. And the highest any ball ever went was 92. And so up to, again, 92 centimeters. That's a pretty strong return bounce. That's pretty awesome for a bouncy ball, for just a super ball. So then we, in this lab, explored how dropping that ball and having it bounce and bounce and bounce and bounce and bounce and bounce and bounce is kind of an infinite series. It is an infinite series, in fact, and we can use our formula, S sub n is equal to A over 1 minus R, to give us an idea of how far that ball traveled as it was bouncing. Well, if we all start at 100 centimeters for dropping it, that way you can see it on the meter stick really well, and you had a return bounce of 92, I asked the kids to figure out what that means for a total distance that the ball must have traveled. All right, so I'm going to pause for a moment, and anybody that was gone, you need to go and figure this out right now using your calculator is allowed, and using the formula that we have, and see if you did it right after I return from the pause here. So I'm going to pause and give you a minute to give that a try. Okay, you're not cheating and listening to this without trying, are you? If so, rise to the challenge and give this a try. All right, so here's how you do it. Your amount that this thing started at, the starting amount, was 100 over 1 minus R. The R is the rate, the thing you'd multiply this by to go from here to here. So we always get R then by going backwards and taking this divided by that. Our second term divided by our first term. So 92 divided by 100. So there you go. And if I change this to decimals, it might make it a little easier. 100 minus, or over 1 minus 0.92, which is 100 over 0.08, which is 1250. Okay, that for right there is what a lot of people thought the answer would be. But here's the catch. That would just be this distance plus this distance plus this distance plus this distance. And people realized pretty quickly that, oh, wait a minute, it's actually got to kind of be doubled, because there's a trip up right here that we aren't counting. And then there's another trip back up right here. And so then the next step was, a lot of kids just doubled it and said, okay, so therefore the answer is 1500. Nope, that's not right either. What do you think is wrong with that? I'm going to pause for a second and let you think that through. Okay, I hope you realized that this is the one that's different right here. There was no bounce up at the beginning. And so if I take off that 100 for the original, that green thing that isn't there, as in there was no trip up this way to start this whole thing off, that's the one thing that didn't get doubled. So I take off 100 for that. That brings us down to 1400. Now, if you go with, okay, so 1400 is my total distance that it traveled. Think about that. That means 14 meter sticks. 1400 centimeters. That'd be 14 meter sticks that ball would travel when you add up all of its ups and downs. And that's a great example of infinite things adding up to something finite, which again blew the minds of the Greeks as they were figuring this out. Why on earth could you add up infinite things and be able to predict exactly with the formula like this what it's equal to? All right, then I had the kids do a little quiz in class. I'm going to pause while I pull that up. Okay, here's the 4 questions that I asked them. So if you want to have this experience at home here, give it a try. See if you can do these 4, and then I'm going to talk you through them. That's what we did in class. So these 4 questions kind of sum up where you should be at this point. All right, so pause this, give these 4 a shot, and then come back and see if you can get 4 out of 4. Most kids were able to pull off a 4 out of 4. No calculators, because on our test, we won't have any calculators. Okay, so we're back from the pause there. Hope you didn't cheat. Hope you actually tried these. That's the only way you get smarter, not from watching me. You're going to remember only 10% of what I tell you, whereas what you do, you're going to remember a much bigger percent of. All right, this sigma is the way to write this in a sigma is go from 1 to, well, it says 10 terms, so 10. And then to put your little formula in here, you go a sub 0, a sub n would be a sub 0, or just a, and then you add d times n minus 1. All right, so our amount 0, our starting amount is 2, plus d, which, do I know the d? Oh yeah, I do. That minus that will give me the difference, and that's 5 times n minus 1. So if I multiply this out, first of all, you could leave it that way. That's a good way to write the sigma notation for this. Or, if you actually simplify this down, it's going to be 2 plus 5n minus 5, which means really 5n minus 3. That's the best thing that you could put right here for your sigma. But if you left it unsimplified, I would have taken it. When you actually use your formula then, which is the first number, which is 2, plus the last number, which you can calculate with one of the other formulas, this guy right here, sticking in the 10th term right here, 10 minus 1 is 9, 9 times the 5 is 45, plus, anyway, you get 47 for your your last term. First term plus last term, and then you times it all by n over 2. Our number of terms was 10. So then we get 10 over 2, which is 5. So 5 times 49, and I'm going to pause for a second, look that up. All right, and that gives me 245. That was my sum of those first 10 terms. All right, under number 2. Number 2 has, if this is a geometric sequence, then what is the nth term? Well, I know the formula for that. The formula for the nth term is a sub n, and for geometric, it goes like this. Your starting amount, sometimes we call it a, sometimes a sub 0, times r to the n minus 1. And I know a for this little sequence, my starting amount is 2, and I know my r in this case is, put a parentheses here, our r is that divided by that, 8 divided by 2 is 4 to the n minus 1. There is the nth term. Okay, the next one. This is one of those infinite series, and so we can use s sub n is equal to a over 1 minus r. And our amount to start with is, once I put in a 1 here, I will get 1/2 to the 1, which is 1/2 is my starting amount, over 1 minus the r. The r, after you look at the first one's 1/2, and then you stick in a 2, and you'll get 1/2 to the 2, which is 1/4. You'll realize, oh, it's actually multiplying by 1/2 each time. So our r is also 1/2. And 1/2 over 1 minus a half is a half divided by a half. And a half divided by a half is equal to 1. Okay. And then lastly, number 4, the hardest one, no doubt. There's 2 equations set up here. One of them is this formula with an 8 stuck in as the second term is 8. And then we put a 2 in because it's the second term. And 2 minus 1 is 1, and d times 1 is the same as d. And that's how we get this equation. 8 equals a sub 0. For those classes that don't use a sub 0, it'd just be a plus d. This other equation, the 12, goes in as the term we're looking for, the nth term. And which term was it? It was the first, second, third, fourth term. So we put a 4 into the formula. And it's kind of like this one. So r minus 1 would give us the 3. And there we go. There's our second equation. And if you, let me see here. If you put the one formula into the other formula, if we put this, solve it for A would be equal to 8 minus D, and put 8 minus D in for A right here, I'll have 12 equals 8 minus D plus 3D. That's just that. And the minus D plus 3D would be plus 2D. And then I'm subtracting 8 from both sides. And I get 4 equals 2D, so D must equal 2. That was the difference for that arithmetic. All right, so there's 4 problems that we did in class as like an in-class quiz in groups. And I hope if you missed class that you were able to follow through that. And that's a great review so that you can be all caught up. I hope you really enjoy your break. Take care.